Section number 12 is entitled Division of Polynomials. First, we're going to review something basic from arithmetic. As you all know, 4 over 2 plus 6 over 2, this is 4 plus 6 over 2. Now, I'm going to concentrate on this side here, but I want you to realize that it comes from there. You cannot just say, oh, this is simple. 2 goes into 4 2 times, and the answer is 2 plus 6, which is 8. The reason you can't do that is because this here equals this. And when I look at the left side, I see that 2 goes into the 4 and the 2 goes into 6. This is not equal. You have to also do 2 into 6, and you get 3. You only do that if it's addition or subtraction. And the answer is 5. After all, 4 divided by 2 is 2, and 6 divided by 2 is 3, and when you add them up, here you get 2 plus 3 or 5. Now, if you have 4 times 6 divided by 2, now you can do the 2 into the 4 and get 2, and say 2 times 6 is 12, or coincidentally, 2 goes into 6 3 times, and you can say 4 times 3 is 12, and you get the same answer. You do not, when it's multiplication, you do not divide the 2 into the 4 and the 2 into the 2, and then say the answer is 6. That's not true. If you had 2 2's in the bottom, you were dividing by 2 times 2. Sure, you can say 2 into 4 is 2, and 2 into 6 is 3, and 2 times 3 is 6. But what I want you to concentrate on is when you have a sum or a difference, you have to divide the denominator into the whole numerator. You had 4 minus 6 divided by 2. You have to divide the 2 into each of the terms. 2 minus 3 happens to be negative 1. When you have a sum, you have to divide the denominator into each term in the numerator. Terms are separated by addition and subtraction. For example, you had 6x to the 4th minus 8x squared, take away 12, and you're dividing this by 2. Now, whether you write what I'm about to write or not, you have to at least think it. It's the first term divided by 2 minus the second term divided by 2 minus because it says minus the third term divided by 2. Whether you write what I just wrote or not, you're going to have to think it. How many times does 2 go in here? Well, 2 goes into 6 3 times. 3x to the 4th. Minus 2 goes into 8 4 times. 4x squared. Minus 2 goes into 12 6 times. Minus 6, and there's your answer. We just divided a polynomial, in this case by a constant 2. Do a similar one. Suppose you have 25x cubed minus 10x plus 60. You want to divide this by 5. Remember, these are the terms. Remember, the terms are separated by addition and subtraction symbols. There's one term, the second term, the third term. The only thing in the numerator that doesn't have a box around them are the terms. Excuse me, the addition and subtraction symbols. They separate the terms. Well, 5 goes into this term 5x cubed times. 5 goes into 25 5 times. 5 goes into 10x 2x times. 5 goes into 60 12 times. And there's your answer. 5x cubed minus 2x plus 12. Plus only because it said it. If it said minus, I would have written minus 12. Suppose you have 8x to the 4 minus 6x cubed plus 12x squared. You want to divide this by negative 2x. So first you want to calculate this. The first term divided by negative 2x. Well, let's do the sign first. There's no sign in the top, so it's understood to be positive. A positive over negative is negative. 8 divided by 2 is 4. And x to the 4 divided by an x to the 1, that leaves x cubed. X to the 4 means you have 4 x's, in this case in the numerator, and you have x in the denominator. One of them cancels out, so you have 3 x's left, which is x cubed. So that's one piece of the answer, minus 4x cubed. Now we need to take the second term, negative 6x cubed divided by negative 2x. Well, a negative divided by a negative is positive. 6 divided by 2 is 3. And x cubed divided by x is x squared. You only had x cubed in the top, and you have 1x in the bottom. Well, 1x on the top gets killed off by 1x in the bottom, and all that's left is x times x, or x cubed. Excuse me, x squared. 3x squared. Now we have to do positive 12x squared divided by negative 2x. And what I'm writing on the bottom, you can do in your head, fine. I'm just telling you, like always, I'm just telling you what you have to think. What you write down, that's up to you. A positive divided by a negative is negative. 12 divided by 2 is 6. And x squared, that is x times x, divided by x, that just leaves 1x. So it's negative 6x. Minus 6x, and here is the answer. And underneath is the work you did. Whether you do it in your head, whether you do it on a separate sheet of paper, whether you do it on the bedroom walls, wherever you do it, that's what you have to do. These are the results you'll get. Wherever you do it, those are the results you should get. Suppose we divide this by x. This division is just going to give you 5x. Because the top, 5x squared, means this. When you divide it by x, you're left with 5x. Minus, for this one, you should see the x's cancel. Get negative 3. Minus 3x over x. The x's cancel, you just get negative 3. And for the next one, you really can't do the division. You get 5 over x. Okay, that problem is said to be done. Let's try another one. This one will be a little bit harder, but not much. Suppose you have have 17 m to the 4 n cubed. And you're taking away 11m squared n to the 4th. And you're adding 12m cubed n to the 7th. And you're taking away 11m squared n squared. And you're going to add 3m n to the 6th power. And you are going to divide this, believe it or not, by m squared, n squared. The question is, what do you get? Well, these are the terms. The first term minus the second term plus the third term minus the fourth term plus the fifth term, all divided by m squared, n squared. So what is 17 m to the 4th, the first term, divided by m squared, n squared? Well, the 17 just stated, there's no integer on the bottom, there's no number on the bottom to cancel. So that's just 17. The m's are lined up. M to the 4th divided by m squared, you subtract the powers. 4 minus 2 is 2. And when it's n, it's just to the first, because 3 take away 2 is 1. So that's the first part of the answer, 17 m squared n squared. Now you have minus 11 m squared n squared divided by m squared n squared, and there's a typo, the top is n to the 4th. Well, the m squared certainly cancel out. So you do get the negative 11, and when it comes to n to the 4th over n squared, 4 minus 2 is 2. So you get minus 11n squared. Okay, let's do the next one. We'll do it right here. 12m cubed n to the 7th divided by m squared n squared. And it's plus. So we're going to get a plus. The 12 stays. 3 minus 2 is 1. So you just get m, which is understood as n to the 1. And 7 minus 2 is 5. So you get n to the 5th. Let me erase my side work. Let me have some more space here. The next one is minus 11 m squared n squared. When you divide it by m squared n squared, you just get negative 11. The next one is plus 3m n to the 6th, and we're dividing by m squared n squared. Well, you get plus 3. Here's the 3. When it comes to the m's, you have more in the bottom. You have 1 more in the bottom. The larger number, the bottom power minus the top power. 2 minus 1 is 1. So you get m to the 1, or just m in the bottom. And since there's more n's on the top, n goes on the top, and you do the top power minus the bottom power, and you get 4. So it's plus 3 n to the 4 m. The largest power of, say, m is on the bottom. You put m on the bottom, and then you do the larger power, in this case the bottom power, minus the top power. 2 minus 1 is 1. And minus some silly error, there is your answer. And I'm checking, and I actually see a silly error. When we did this division, 3 minus 2 is 1. Underneath, it should say 17m squared n. Shorthand for n to the 1. Minus 11n squared plus 12m n to the 5th minus 11. Okay, the rest looks fine. if you notice, each problem we've done so far, the denominator just had one term. That is, we didn't have things being added. Maybe we had things being multiplied in the denominator. So far we divided by 2, we divided by 5. 2 is one term, 5 is one term. We divided by, I think, negative 2x, which is one term. We divided by x, one term. We divided by n squared, which is one term. I know they're each one term. There's no plus or minus sign separating the terms. Why? Because it's one term. Now we're going to divide by two terms. And that changes the whole way of doing this. Up to now you may have said, oh, division of polynomials, very, very simple. Unfortunately, that's not true. Let's think of a good problem. Suppose we wanted to divide this by x plus 4. Okay, but let me actually state that. We want to divide by x plus 4. Now, if you had, say, 10 and you wanted to divide by 5, well, either that means 5 into 10 or it means 10 into 5. I'll give you a hint, it's not that one. You reverse the order. The 5 comes first, then the 10 comes second. That is, we want to do x plus 4 into x cubed minus 10x plus 24. That's what we want to do. Except we're not going to do it the way it looks. We need to write what's out here in descending order, which is x to the 1 plus 4x to the 0. Remember, x to the 1 can be written that way, and 4 is the same as 4 times 1, but x to the 0 is 1. The powers descended. They don't have to be in order. That is, you could have had in front 3x to the 7 plus 2x cubed plus 9, and that would be fine. The power of x is 7. The power of x is smaller, it's 3. The power of x here is 0. If instead of dividing by x plus 4, we were dividing by this, we would leave it that way. If, on the other hand, it was 2x cubed plus 9 plus 3x to the 7 that we were dividing by, we would write it like this, in descending order. The x plus 4 is in descending order. What goes underneath this strange bar has to not only be in descending order, but it has to have the missing terms. You have to fill in the missing terms. The degree of this is 3. We have 1x cubed. We have no x squares. Straighten out the bar, please. We have no x squared. We have negative 10x's, and the constant is 24. We had to fill in the x squared term. Okay, now the problem starts. So you go from the top line right to this. Now you ask yourself, how many times does x goes into x cubed? That is, what do you multiply x by to get x cubed? Now, the power of x is 1. Just ask yourself, 1 plus what gives you 3? And the answer is 2. Now, just like in ordinary long division, if you had this problem, 3 would go here. You would say 2 times 3, and you would put that answer here. And then you would subtract. So I'm going to take what's on top of the bar, x squared, and multiply it by what's in front. And I get x cubed plus 4x squared. X cubed plus 4x squared. And now we want to subtract, but before I subtract, let me make a comment. Notice how the x squares are lined up now. If I didn't fill in that missing term, I would have had x cubed minus 10x plus 24 for the first line, and then I would be taking away x cubed plus 4x squared, which is a bit messy calculation to do because what's in this middle column, they're not like terms. X is in x squared. So that's why I filled in the missing terms, so that wouldn't happen. Now, the next hard part for students, subtraction. You need to know how to subtract. By design, x cubed minus x cubed cancels out. You have 0x squared, and you are taking away 4x squared. What's 0 minus 4? Well, if you read it backwards, you'll almost have the answer. 4 minus 0 is 4. Change the sign, and you'll have the exact answer. Negative 4 what? X squared. And I like to bring everything down. Minus 10x plus 24. Now, it's a brand new problem again. The x in front, the leading term, not x plus 4, but just x. What do you multiply the x by in front to get negative 4x squared? What do you multiply x by to get negative 4x squared? Well, you're going to have negative 4 to get the negative 4. And to get x squared, x times x is x squared. So what do you multiply x by to get negative 4x squared? What do you know? It's right there in the brackets. Negative 4x. Then you take the negative 4x and you multiply it by x plus 4. And you get negative 4x squared minus 16x. And that's what I write here. Negative 4x squared minus 16x. And I subtract. When you subtract the exact same values, you get 0. Negative 4x squared minus negative 4x squared is 0. Negative 4x squared minus negative 4x squared, that's 0. Negative 10 minus negative 16. This is negative 10 plus 16, which is 16 minus 10. It's 6. 6x's plus 24. You have to design your own taste, technique, style of adding and subtracting numbers. And there's a reason people mess up is because they try to do it by memorizing some rules. It doesn't work. Not to be rude, but if it worked, you wouldn't be having trouble with this. That, of course, is only for the students who are having trouble. What do you multiply x by to get 6x? I would hope the answer is obvious. You multiply by 6. X times 6 is 6x. You multiply the 6 by what's in front, namely x plus 4, and you get 6x plus 24. Remember, when you subtract the same things, and these two last lines, they certainly look the same to me. When you subtract the same things, you get 0. Okay, and since the remainder is 0, you're done. There is your answer. The top line asks, what is x cubed minus 10x plus 24 divided by x plus 4? How much is that? I can now tell you. It's x squared minus 4x plus x. And if you wanted to check, just like if you wanted to check 2 and 2 24 and you said 12. You would multiply 2 by 12 and check to see if you get 24. If you wanted to check this, you would multiply x plus 4 by, what's the top? What I just put in the brackets. And check to see if you got x cubed minus 10x plus 24. And if you did, you have the right answer. If you didn't, then you have the wrong answer. This is assumed that you didn't make an error in your check. If you do the check correctly, if you don't get the right answer, well then you have a mistake in your answer. Try one more. Suppose you have a cubed minus 8, and you want to divide that whole mess by a minus 2. That is, you want to do a minus 2, which is in descending order, into this. This is the cubic. We have 1a cubed, we have no a squares, we have 0 a's, and our constant is negative 8. A times what gives you a cubed? 1 plus 2 gives you 3. So a times a squared gives you a cubed. Now you take the a squared on top, you multiply it by what's in front, you get a cubed minus 2a squared, and you subtract that. A cubed minus 2a squared. Notice the a cubed and the a squared are lined up. Now, you really need to get into the following habit. If somebody asks you, how much is this? How much is this? You really need to say, I don't know. I personally don't know. The answer is either probably 12 or 8 or 20. Possibly 5, but I wouldn't put my money on 5. If you were adding, it would be 12. If you were subtracting, it would be 8. If on the other hand you were multiplying, it would be 20. Personally, I've never really seen a problem that looks like that, but it could have been that, and that would give me 5. So what am I trying to get at? What I'm trying to get at is, before you dare do some arithmetic, that is add, subtract, multiply, or divide, you better know which one it is. You best look for that sign there. And if that sign isn't there, either the problem can't be done, or you better figure out what that sign is. And I clearly put it down here. It's subtraction. A cubed, take away a cubed is 0. 0a squared, minus negative 2a squared. Well, that's not 0 minus 2, because that's not 2. So if it's not 0 minus 2, it's 0 plus 2, which of course is 2. 2a squared. I'm bringing down the rest. Plus 0a minus 8. Before you combine, know what the operation is. And I'm not asking for much in that. You cannot combine things unless you know what the operation is. Now we kind of start all over again. A times what gives you 2a squared. A times what gives you 2a squared. Now you can think of this in two ways. There's an understood 1 in front. 1 times 2 gives you 2, and a times a gives you a squared, and there's the answer. Or, if somebody asks you a times what gives you 2a squared, what they're really asking is, what is 2a squared divided by a? Well, 1a in the bottom kills off one of the 2a's in the top, So there's only one a left on the top, and you get 2a. Just like we got before. And 2a is positive. Positive 2a. Now, we take positive 2a, and we multiply it by what's in front. A minus 2. And you get 2a times a is 2a squared minus 4a. 2a squared minus 4a. And we subtract. 2a squared minus 2a squared is 0. 0 a's minus negative 4 a's is 4. It's not 0 minus 4, so it must be 0 plus 4, which is 4. So we have 4a minus 8. Okay, every time you have a remainder, we try again. You take the leading term in front, which is a. What do you multiply a by to get 4a? The answer is 4. You take a, what do you multiply a by to get 4a? 4. 8 times 4 is 4 times a. So you take the 4 from the top, you multiply it by what's in front, you get 4a minus, and 4 times 2 is 8. So that's what we subtract. Oh, those two lines are identical. So when I subtract, I'm going to get 0. If you don't see that, fine. You have 4a and you're taking away, oh, the same, 0. You have negative 8 and you are taking away, oh, the same. I get 0. I see students going crazy to do a problem like this. Every one of these same students will know x minus x is 0. Oh, I'm just telling you what x is. X is negative 5. Besides, when you subtract, you find out how much bigger one number is than the other. These numbers are exactly the same. They differ by 0. When you subtract the same numbers, you get 0. Most of you would know that 7 minus 7 is 0. Good. But now you need to know that negative 7 minus a negative 7 is 0. If you have the same two numbers and you put this little horizontal line in between them, you better put two parallel horizontal lines with a big O in the end. That is, when you subtract the same two quantities, you get O. You get 0. Okay, so since the remainder is 0, minus some silly error, what's on top is the answer. That is, when you do that division on top, you get a squared plus 2a plus the number 4. If you want to check, you should multiply this by a minus 2, and you should get this. But remember, that's just a cubed minus 8. Because 0a squared is 0, 0a is 0, and adding the zeros even 2 times doesn't affect anything. Adding 0, you ignore. Somebody asked me, what's 7 plus 0 plus 2 plus 0 plus 3? I would say 7 plus 2 is 9 plus 3 is 12. I ignored the zeros. Adding 0 is not going to change anything. In multiplication, you shouldn't ignore 0, but you should ignore 1. Multiplying by 1 doesn't do anything. In fact, multiplying by 0, the answer is done. The answer is 0. Okay, let's try one more. Suppose you have 4 plus x squared, and you would love to divide that whole thing by 1 plus x. So this goes first, but we put it in descending order. X plus 1, the bar. This goes next in descending order, and we fill in the missing terms. We have x squared plus no x's plus the number 4. What do you multiply x by to get x squared, x. Then you take what's on top, namely x, which you just put on top, and you multiply it by x plus 1, and you got x squared plus x. X squares are lined up. Oh, the x's are lined up. Then this is x is understood to be 1x. Now you subtract. X squared minus x squared is 0. And now we're subtracting x's. We have 0, and we're taking away 1. That's negative 1. I mean, after all, if you had 0 and you take away 1, you're at negative 1. Plus 4. What do you multiply x by to get negative 1x? Negative 1. Take negative 1, you multiply it by x plus 1. Negative 1 times x, like we said, is negative x or negative 1x. And negative 1 times 1 is negative 1. So we take away negative 1x minus 1. We subtract this. This minus the same thing is 0. The next problem, it's 4 minus negative 1. Since what we're taking away is not 1, then it's not 4 minus 1, it's 4 plus 1, or 5. Now, we didn't talk about this yet, but once the degree of the remainder, remember, 5 is 5x to the 0. The degree of 5 is 0. The degree of this is 1. Once the remainder has a smaller degree than what you're dividing by, you stop. It's just plus the remainder, 5, divided by what we're dividing by, x plus 1. And that's the final answer. That is, that division on top is x minus 1 plus 5 over x plus 1. And we'll actually bother to check this one. Remember, 10 divided by 2 is 5. 5 times 2 will give you 10. I'm going to take x minus 1, I'm going to multiply it by this. That is, this product should give me x squared plus 4. Okay. 1 plus x, I'm just going to call it x plus 1. Multiplied by x minus 1 plus 5 over x plus 1. I'm going to multiply by the 5 over x plus 1 at the end. I'm going to do x times x. That gives me x squared. I'm going to do x times negative 1. That gives me negative 1x. I should be doing that one, but I'm not going to do it yet. I have to do it. When I do, it's up to me. I need to multiply 1 times x. Oh, that's 1x. I need to multiply positive 1 by negative 1, which is negative 1. And I need to multiply the 1 by the 5 over x plus 1. In fact, I didn't multiply any of this by the 5 over x plus 1. Well, I'm going to do it all at once. I'm going to do it all at once. This whole thing times 5 over x plus 1. X plus 1 times a positive 5 over x plus 1. The x plus 1's cancel out, and you just get plus 5. Okay? Plus 5. You take away x, and then you add x back. There's no x's. So I have x squared, and if you take away 1 and you add 5. If you're at negative 1 and you add 5. 1, 2, 3, 4, 5. What it's asking is, what number is right there? Well, I don't know. Let's see. 0, 1, 2, 3, 4. 4 is the answer. If you owe me $1 and you give me $5, you now have $4 credit. plus 4. If I didn't make any mistake, that should be that right there. And it is. X squared plus 4 is 4 plus x squared. Addition commutes. So you can definitely check these. If you have time on an exam, you definitely should. Okay, so hard section, go over it. Our next section is going to be solving linear equations.